Okay, so today we're going to start with the topical past paper, and the topical past paper is the energetics, means the endothermic and exothermic topic. We're going to do the hard questions today. So the question number one is chlorine and ethane reacts together in the exothermic reaction. They react together in exothermic reaction to produce the chloroethane, and the hydrogen chloride is formed. So the reaction here is a reaction. This one is a ethane, and reacts with the chlorine, forms a chloroethane and the hydrochloric acid. So the formula of a ethane is carbon with a 2 1 second, let me draw neat diagram. One single bond of hydrogen, then you have a chlorine single bond here. Then on the other side, the new bond is formed. That is a carbon and chlorine. This new bond is formed. The remaining all bonds are the same. Only this bond is broken down. Okay. And the chlorine and chlorine is bond broken down. So the bond broken is the hydrogen and carbon and hydrogen bond is broken down. This one is bond broken. Okay, and the bond that is another bond that is broken on the reactant side is the chlorine chlorine bond. So this one is a bond broken of a chlorine. Then the new bond is formed is between the carbon and chlorine. The new bond is formed is a carbon and chlorine, which I'm going to represent with the red color, so we can identify that. So this one is a bond making, and the new bond which is formed is a hydrogen and chlorine. The hydrogen and chlorine bond is formed here. Okay, now this one is a another bond make. Now only the single bond is formed. Single bond of a hydrogen and carbon is broken down. Single bond of a chlorine is broken down, chlorine molecule, and the single bond of a carbon and chlorine is formed, and the single bond of a hydrogen and chlorine is formed. So now the bond making addition, sum of bond making, and a sum of bond breaking. So the bond breaking are 240 plus with the 410. What answer you will get? Please give me the answer. Take your time. 650 for the bond breaking is the 650 kilojoules per mole. Okay. Then the bond making is 770 kilojoules per mole. 770 kilojoules per mole. Now, now the delta H. To calculate the delta H, we are going to use a formula. Delta H is equal to energy needed to break the bond, means the bond breaking, subtracted by the bond making. Bond making is subtracted by the bond making. So the bond breaking is 650 here, subtracted by the bond making, that is 770. So the answer is minus 120. The sign is very important here. This will identify the type of a reaction, whether the reaction is exothermic or the endothermic. So the correct answer is B is the correct answer. Is it clear to you? Yes, there is a correction here. The correct answer is the By mistake, I have select the B one. The correct answer is A, which is minus 120 kilojoules per mole. Now the next question. The production of ammonia involves the exothermic reaction. The type of exothermic reaction is the production of ammonia between the nitrogen and hydrogen. They have already mentioned here the type of a reaction is exothermic, and the reaction is between the nitrogen and hydrogen. The equation for the reaction is shown. So we have a equation of a reaction. Here is the equation of reaction. The table shows the bond energies. So for this, nitrogen molecule is triple covalent bond with each other, and this one is the only one mole of a nitrogen molecule. Then you have a hydrogen molecule, sorry, not the oxygen. Hydrogen molecule are single covalent bond, and they are the 3 moles of a hydrogen molecule. So 3 will be multiplied here. Then you have a ammonia. In the ammonia, nitrogen and hydrogen are there are the 3 bonds of a nitrogen and hydrogen, and we have a 2 moles of a ammonia is formed. It we can write this in the different way like this, means the 6 3 multiplied by 6, because the total 3 bonds are present in the each molecule. So 3 multiplied by 2 become a 6 here. So 6 multiplied by NH. Got it? Now the NH will multiply with by the 6, which is a new bond making, and with the red color I'm going to show the bond breaking. So 3 multiply with the hydrogen, so this one will be the bond breaking, and the second one only one, so this one another bond breaking here. Now let's move forward. For the bond breaking, 3 multiply by 436 plus 945, and for the next one bond making, 6 multiply by the value is 390 here, so 390. Yes, please. Bond breaking is 2253 kilojoules per mole. 2253 kilojoules per mole. And the next one is 2340. 2340 kilojoules per mole. The formula is what? Yes. Can you please speak the formula? Bond bond breaking means the BB minus by BM. Okay. So the bond breaking is 2253, and the bond making is 2340. So the answer is minus 87 kilojoules per mole. So correct option is C here. C is the correct option. Okay. Now, any question here? Okay. Now the next one. Chlorine and hydrogen reacts in an exothermic reaction producing hydrogen chloride. The equation for the reaction is shown here. Here is the equation for the reaction. The table shows the bond energy involved. The total energy change for this reaction is this. This one is a delta H value, total energy value. Now, what they are asking on the other page, what is the energy of the chlorine? So this one is missing here. I'm going to write the equation here. Let me check the equation. What is the equation? Chlorine and hydrogen are bond making. So the chlorine reacts with the hydrogen, forms 2 moles of hydrogen chloride. Why I have checked the equation? Sometimes this equation is a reverse, means the chlorine hydrogen chloride is broke down into a chlorine and hydrogen. So now for the bond making and the bond breaking, chlorine is unknown, so this value is unknown here of a bond breaking. The second one is hydrogen. So this one is a bond breaking another 1 mole of hydrogen. Then you have a 2 moles of a hydrogen chloride here, which is a bond making here. Now the delta H is equal to bond breaking minus 2 bond making. Am I right? Okay. You have to show the thumbs up now here if I'm right. Now the next one. So for the delta H, let's check the delta H value. The delta H value is minus 184. So minus 184, we have a 1 minus 184 here. Bond breaking, the chlorine is unknown. So I'm going to write the chlorine as an unknown here. Plus with the hydrogen is 436 bracket minus 2 multiplied by 4, 430. So it will be a 4860. Am I right? Now this value moves to the other side. This value moves to the other side. This value moves to the other side. So it will become a chlorine is equal to positive 860 minus 184 minus 436. Yes, please give me the answer. Minus 2 4 minus or positive? Positive, very good. Positive 240 kilojoules per mole is the correct answer. So B is the correct answer as the positive sign is here. Okay. So A, C, D is not the correct answer. Now the next question. In the next question, methane combusts in oxygen as shown, producing a energy change from this kilojoule per mole. Change of energy. This one is an energy change. So this will be the delta H. Okay. They are asking for you the for the CO. Energy is missing here. So the methane and oxygen forms a carbon dioxide and water here. So we have to do some calculation here. You have to note down those calculation. Then we move to the next part. Hydrogen and hydrogen and sorry, carbon and hydrogen bond. So there are the 4 carbon and hydrogen bond. Carbon is bonded with the 4 hydrogen. So we have to multiply with the 4 here. 4 multiplied by this. What answer you get? 1640. Then the oxygen are the 2 moles here. So this will multiply with the 2. What answer you will get here? 992. Then the water. In the water molecule, oxygen is bonded with the two hydrogen atom, and this one is the 2 moles of a water molecule, so it will become a double. So 4 hydrogen and oxygen. 4 multiplied by this, what answer you will get? 1840. Okay. Okay. Did you note down these values? Now, I'm going to write the equation here for the reference. Methane, 2 moles of oxygen forms carbon dioxide and 2 moles of water. For the carbon dioxide, carbon is bonded, double covalent bonded with the 2 oxygen atom. So it means that this value will be a 2 multiplied by carbon double bonded with oxygen. So we consider this part is an unknown here. So we're going to consider this part as a 2x unknown value. Now the calculation is delta H is equal to bond breaking minus to the bond making. Yes. So the bond breaking is oxygen and hydrogen. These are the two bond breaking. At these two values, 992 plus 1640, 2632. So 2632 minus 2x unknown value of carbon dioxide plus with the value of another is 1840, positive 1840. Delta H value, the delta H value is what? Minus 890, minus 890. Now this value move to the other side, the minus will multiply with the whole bracket, so minus 2x and the minus 1840, then you will get minus 2x. So the minus 2x, we're going to write the minus 2x here, all the numbers on the other side. So minus 890 minus 2632 and positive 1840. As this value was become a negative, when we move to the other side it becomes a positive. Got it? Now solve this area and give me the answer. Minus 1682, minus minus cancel out, 2 will divided by this. What answer you will get? Quickly. No. 1682 divided by 2. 1682 divided by 2, you will get the answer positive 841. Positive 841 kilojoules per mole, which is D is the correct answer. Now the next question. An energy level diagram is shown here. We have an energy level diagram, and this energy level diagram 1, 2, and 3 points here. Which row is correct for the point labeled in the energy level diagram? Now, if we observe this energy level diagram, so this diagram is for the endothermic reaction. The type of a reaction is what? Endothermic here. Okay. In the endothermic reaction, the reactants are always below and the products are always above. Means the more energy is required to make the products are at the higher energy level, so they require the more energy for to become a product here. Means the reactant have to convert into the product, so the reactant requires the more energy to make the product. Got it? Now, so this one is a product here. The 3 is the product. Now, for the 1 and 2, in the endothermic reaction, the activation energy is always high. This one is the activation energy, which is represented by EA, energy of activation. So, the 1 is the activation energy. Then, for the next one, okay. Now, for the next one, third is complete, one is complete. Now for the second one is the energy change. That is delta H. Energy change. Okay. Now, so activation energy. One was the activation energy. Second was the energy change, that is delta H, and the third was product. So D is the correct answer here. Any question here? Now let's move to the medium questions. Now, question number 1. Which of the process is endothermic? Mostly the endothermic process is the breaking process or removing a water. Means the decrystallization or hydration and the dehydration. Hydration means the addition of a water. Dehydration means the removing of a water. Okay. So reacting of a sodium with the water. The reacting of sodium with the water is the exothermic reaction because the heat energy is generated. Okay, the reaction is very violent reaction. So A is not our answer. This one is what? Exothermic. When the metals. So from here we can say that exothermic. From here we can say that the group number one reaction with water is exothermic. Use of a petrol in an engine. Use of a petrol in an engine. This one is also another exothermic reaction. Heat energy is produced. That's why we use a petrol. Obviously, we otherwise if we going to use a ice, if we don't require any heat energy to be produced, huh? So the substance which we required here too is the substance that can produce the heat energy. Okay, so the petrol will produce a heat energy, so all the heat energy producing are exothermic. And the type of reaction which is done in the engine, the type of reaction is a combustion reaction. So the combustion reaction is a exothermic reaction. All the combustion reaction are exothermic reaction. We are searching for the endothermic here. Distilling crude oil. Distilling crude oil. Burning a fossil fuel again. This one is another one. Fossil fuel is another exothermic. So all are the exothermic here. Only we are left with the C. So C is the correct answer. Now you will be confused. Is the crude oil distilling is crude oil is the exothermic or the endothermic? You have to work on the three. The three are the correct, and you have already studied detail of the three of the options. So three are belongs to the exothermic. So definitely the C is the correct answer. Now, distilling of a crude oil. Distilling of a crude oil means what? It requires the energy. The crude oil is not it by self break down into a substance, means it's not by self starts boil. So it required a heat energy to boils the its components, means the fractions that comes out from the crude oil. So the heat energy is required to heat up the solution. The crude oil is a solution of a different component. So they come out in the form of a vapors, and they cool down, and they are separated from the crude oil. Got it? So first the reaction is start with the endothermic. Got it? Later on it's a exothermic, but the first the reaction is the endothermic reaction. In all chemical reaction, bonds in the reactant species, all chemical reaction, the bonds in the reactant species are broken. New bonds are formed in the product. Which statement is correct here? Yes. Let's read one by one. The bond breaking required energy. Bond breaking required energy and is does exothermic. If the energy is required, so the type of reaction is not a exo, it's a endo. This one is wrong. Bond breaking requires energy and is does an endothermic. So I have already correct above. So B is the correct answer. No need to discuss the other two, but we will discuss to clear our concept. Bond breaking is a release energy. Does is a exothermic. Bond breaking is not a release energy. Already we have discussed it requires the energy. So C is not correct here. Bond breaking is release energy. Does is a exothermic. In the release of energy, endothermic is not type of reaction process. The process is the exothermic process. So D is not our choice. Clear? Now the next question. Yes. Next question is which is true about a chemical energy changes? Chemical energy changes. We have to check the true and false here. True statement. Type of reaction, energy flow, and the temperature of surrounding. The type of, if we start from here, it will be difficult for us to solve this numeric this MCQs now. Okay. So from where we going to start? We are going to start from other columns like the temperature of the surrounding and the flow of energy. So temperature of the surrounding is increasing. If it is increasing to the surrounding or from the surrounding. Okay. We can also check by the exothermic and endothermic. This one is a difficult one. So sometimes I told the student to solve the one by one column, but we have to read the whole statement. Now let's read the whole statement. Exothermic to the surrounding, it gives the energy to the surrounding. Temperature is increase the surrounding. So is the surrounding temperature is increases? Yes, A is the correct answer. Okay. Exothermic from the surrounding. No. If it's from the surrounding, then it is a endothermic, not a exothermic. Endothermic to the surrounding, wrong. To the surrounding, it will be a exothermic. Endothermic from the surrounding, so from the surrounding temperature is not increase. This one is will be a decrease. The two statements are correct, but the third one is wrong here. Now, question number 4. The reaction profile for making nitrogen monoxide. Nitrogen monoxide is shown below. We have a equation here. Reactants are below and products are above. So the type of reaction is what? Endothermic. The amount of this one is a amount of activation energy, and this one is what? Delta H. This activation energy which is not becoming a part of a reaction. This curve is not becoming a part of a reaction, is give in and the give out in the same amount. This area is used in the reaction. Okay, so if we add these two values 180 and the 140, if we add the 180 and the 140, you will get the complete total activation energy. This one means the 140 is the subtracted activation energy from the energy. Got it? So they are asking for the total activation energy. What is activation energy for this reaction? So the total you have to add 140 and the 180. The answer is 320, and the answer must be in the positive way. Why? Because in the endothermic the arrow of the activation is always above. Above arrow is the positive one, below arrow is the negative one. Above arrow is what? Positive one, and the below arrow is negative one. So 320 positive, C is the correct answer here. Now the next question. Endothermic reaction can be used in emergency sports injury treatment packs. Endothermic reaction, na? Endothermic reaction means what? Heat energy is absorbed or released. It's providing the heat energy. Endothermic reaction can be used in energy sports energy emergency sports injury treatment packs. So endothermic reaction is done there, na? So it providing the heat energy or it releasing the heat energy. Okay, what is the true about this pack? Okay, absorb energy from the surrounding and transfer to the injury, can be reused, usually contain ammonia nitrate and water, is separate component compartment. C is the correct answer here. Okay. Most sports injury cold packs contain ammonia nitrate and water, which reacts endothermically when mixed together. Got it? So they provide the heat energy. Now we are done with the medium and the hard part. The easy one will be done by you right now. I'm going to send you the file.